Hello everyone, this is Vasant, 9-pointer at IIT Bombay from the Department of Civil Engineering. Today we are going to solve a problem on axial loading. So in previous two classes, we solved A, B, C, D, E parts of this problem. Now we are going to solve F part of this problem. So we got R1 is equals to minus 3p by 2, N1 is equals to 3p by 2, N2 is equals to p by 2, right? And we solved C, we got x is equals to L by 3, delta 2 is equals to 2pl by 3a. We solve this, we got beta is equals to 1 by 11. Now we are going to solve F part. Draw the axial force diagram and axial displacement diagrams using results from parts B through D. So in F, axial force diagram. Axial force means it is the internal forces developed due to the axial load. तो उसका ग्राफिकल रिप्रेजेंटेशन को हम बोलेंगे एक्सियल फोर्स डायग्राम AFD. So this is n of x and this is length, right? So and we already take, it is mentioned in the question that we should go from B through D, sorry. So we already took x value is equals to L by 3, okay, which we solved in part C. L by 3 and L. So 0 to L by 3 is segment 1, right? L by 3 to L is segment 2. So we already solved that N1, which is internal axial force in segment 1, is 3p by 2 and N2 is p by 2. So this is 3p by 2 to L by 3. So assuming p is positive, okay, and this is p by 2. Okay, this is the axial force. So this is 0.1, this is 0.2, this is 0.3, right? So if you see 2 plus, means just after 2, the value of n is p by 2, right? If you see 2 minus, n is equals to 3p by 2, right? So there is discontinuity at 2. So that is jump discontinuity, right? It is jumped from 3p by 2 to p by 2. Jump discontinuity. इसका value 2 plus minus 2 minus. So that is minus p, right? Minus p is the jump discontinuity, jump value. So from basic mathematics, we know that if a function is discontinuous, I can say graph discontinuous at a point, then value of that function is not defined at that point. Okay, means f of 2 means n exactly at 2.2 is not defined, because see 2 into 2 plus the value is p by 2 and 2 minus value is 3p by 2. So just at 2 there is occurring what we say transition is occurring from 3p by 2 to p by 2. So the value at 2 is not defined. Okay, this is from basic math. So this is axial force diagram. Now we will go to axial displacement diagram. This means elongation diagram, means displacement of each and every particle along the length. Okay, So again, this is delta of x. This is length. I want to say every delta x1. You take any point at x distance, and delta x1 will be is equals to del x minus del 1. So del 1 is 0 is equals to del x, means elongation of bar in x1 part of x1 part. Okay, right? So we already know that at 1 the value is 0, 0.2 is at L by 3, and this is L, this is the length. Okay, so at L by 3 we already solved. If you see the question, see, we already solved for del 2, that is 2p L by 3a, right? So that is 2p L by 3a. L by 3EA, and we already solved at 3 point, at point 3, that is PL by EA, because that is the condition of question C, right? So at point 3 the displacement should be PL by EA. So we have 2 points. So one thing I want to say, see, in segment 1 and in segment 2, in total segment 1 the value of internal force is constant, right? In segment 2 the value of internal force is constant. So see, if the value of internal force is constant, if this is distance x and this is some force P, then what is the value of del x? That will be that force Px divided by EA, right? So for segment 1 it is 3p by 2e into 3 by 4a into x, right? For segment 2 delta 2 plus that p by that force in segment 2 is p by 2, right? P by 2 e into a into that, what is the value if we take that as x? We need to take x minus L by 3, right? See, some point in segment 2 if you take, this is x, and we already covered displacement of this point, this is L by 3, then this should be x minus L by 3, right? So this is for segment 2. See, both are linear, so both are straight lines, so you need to just connect these two lines. So this m12 का स्लोप है 2p by EA, राइट? इसका स्लोप है PL by 3EA divided by 2L by 3, right? So P by 2EA. So this is M23 का slope. So M23 slope is less than M12. That is the reason this angle theta 2 is less than this angle theta 1. With this we end today's lecture. Next lecture we are going to solve another problem. Until then, take care. Bye bye from Manpower.